Many of us learn from as early as elementary school that clouds are made of water droplets. But how do these clouds actually form?
Some methods that are passed around are that clouds are formed when water vapor simply rises and collects, or that they appear when ice crystals form due to a low temperature in the sky. While these ideas are not entirely wrong, they are also not entirely correct either.
Let's go back and take a look at the second way. One pathway of cloud formation is indeed achieved through the formation of ice crystals, but it's a bit more complicated than just simply freezing out of thin air, which you can visualize as ice appearing by itself in front of you suddenly.
In order to freeze ice crystals in the air to make clouds, it helps if there is a surface for this freezing to occur, acting as the center and origin point of the crystal. This is called ice nucleation. As Dr. Seifried puts it,
so if you have a water droplet in the atmosphere, and that water droplet is about, say, 10 micrometer in size, so that would be like a kind of a cloud droplet, and that can super cool down to minus 38 degrees Celsius. So it means like a water droplet does not necessarily need to freeze at 0 degrees Celsius at atmospheric pressure. So that's something people sometimes don't know. It can actually remain in this super cooled state. However, if it collides with a so-called ice nucleating particle, freezing can occur at higher temperatures.
These surfaces are known as ice nucleating molecules, and their name describes their purpose, to act as a nucleus for ice to form around.
Some examples of these particles include dust, soot, or volcanic ash, but there are also many biologic alternatives such as fungal spores, bacteria, and pollen. These tiny specks can help water freeze around them, like an ice train in nature. In this video, we'll be covering pine trees as a source of these particles.
We categorize clouds basically in 3 different types. So there are the clouds which are really close to the surface of the earth, and they are liquid. And then the ones which are a little higher up at around, say, 4 kilometers, they're mixed phase clouds. So they consist of water droplets and ice crystals. And then the ones which are really high up, like about 8 kilometers, they're purely frozen. So to come back to the paper, I studied in that paper whether Pinus sylvestris trees could be an emission source of particles who are ice nucleation active and could change the phase state of a cloud from a liquid to a solid one.
in conclusion, there's more to the formation of clouds than what we might initially think. There's more work to be done and discoveries to be made about these ice nucleating molecules.
To find out more about the implication of these findings, also see our podcast Snap Science.